All right, spring 24, exam 2. I'm going to redraw this circuit now. I have a 12-volt battery right here. I come up to my 6 microfarad capacitor. And then notice that right here I turn into two branches. One of them goes to a 4 microfarad up top, and then the other one goes to a 1 microfarad. Then, as I come along the top here, I come to another junction. Down here, it seems like I come to a junction, but notice that this goes straight back to the battery. So I'm going to deal with what's up top here. As I come up here, I break into another junction. A number of you missed this, by the way, where I didn't get this two microfarads in parallel. And then those two microfarads, after I go through those come back together right here, and they come back together with the 1 microfarad so that the total circuit looked like this. Then I can combine those two microfarads. That gives me a 4 and a 4 in series. And still that 1 down all by itself. Then that 4 and the 4 makes 2, 1 over a quarter plus a quarter. That's equal to 2. And then the 2 and the 1, 2 plus 1 is equal to 3. So I'm going to jump ahead one step and just have a 6 and a 3 microfarad, 6 microfarads, 3 microfarads. You might have stopped right there, but I'll go ahead and redraw the final equivalent circuit, which is 2 microfarads with 12 volts. Now, I know that this capacitor is going to have 24 microcoulombs. That means this will have 24 microcoulombs and this will have 24 microcoulombs. So because capacitors in series have the same charge, then I can figure out the voltage. This is going to be 4 volts and this will be 8 volts. Notice the big capacitor has a small voltage, small capacitor has a big voltage. That 4 volts carries through here and here, so I know those. In fact, I think that was finding the charge. Yeah, the charge on C1 is one of the questions, so I'll go and do that. That was 24 microcoulombs. But then I also want to know the voltage across this capacitor, so I need to dig a little deeper. So I have 8 volts across this capacitor. That means I have 8 volts here. And then I have 8 volts across these two capacitors. That means I have 4 volts and 4 volts because they're identical and they split up that voltage. So 8 volts here, 4 volts here, and 4 volts here, and 4 volts here. Those two capacitors in parallel share the same voltage. So the voltage across C5 is 4 volts. So there's this circuit. Let's do the same thing. We'll redraw it. Let's see, I'll do it down here. 12 volt. I come to my 3 ohm resistor, and then I have a 6, 3, and 2. And the 6, 3, and 2 have an equivalent of 1 ohm. 1 over a 6 plus a third plus a half is equal to 1. And so my equivalent is going to be 4 ohms. Excuse me, yeah, 4 ohms with 12 volts there and there. That means that my currents, I can figure out my current here. My current here is 3 amps. That's 12 divided by 4. 3 amps and 3 amps. Then to find my voltages, I would just say, well, 3 times 3 is 9 volts, and 3 times 1 is 3 volts. 9 plus 3, notice, is equal to 12. So now carrying that up here, I have 9 volts, 3 volts here, 3 volts here, and then I have 3 volts across these two capacitors, which means I have 1 amp going through those two resistors. So that means I have 1 volt and 2 volts, which jives because 1 plus 2 is equal to 3, and the small resistor has the small voltage. So let's see what our answers are. The voltage across R3 looks like that's 1 volt. The current through R1, that was 9 volts divided by 3. Well, I had it down here actually, 3 amps. And then the power dissipated in R2. R2 has V equal, I'll do it right here, V is equal to 3 volts, R is equal to 6 ohms. I could do V squared divided by R, that's my power. Since I have those values, I'll just do that. So that's 3 squared divided by 6, 9 over 6, which is 3 halves, or 1.5 watts. Now I want to consider this multi-loop circuit. What is the current through the 1 ohm resistor? So that's the current through this resistor. I'll call this I2. All right, so first I'm looking for I2. I'm going to write the loop rule for the left loop. I'm going to start right here. Let's call this I3, and I'll call this I1. Um, yeah, it doesn't really matter what you call them. But the first thing I'm looking for is I2. What is I2 equal to? All right. So I'm going to write the loop rule for the left loop. That's going to be plus 1, 1, um, minus 4, minus 1 I2. So that's negative 3, negative I2 equals to 3. All right, yeah, so I2 is equal to 3. I2 is equal to negative 3 amps. I didn't ask for the direction, but it would be 3 amps is the answer through the 1 ohm resistor, and it's going to be down since I chose it up. I didn't ask for the direction here, so I didn't count off. What is the current through the 2 ohm resistor? To find that current, I'm going to do the big loop. So let's start here again. I'm going to go in this direction, so that's going to be plus 1 plus 2I1 equals to 0. And so I1 is equal to negative 1/2. Um, I had called that down, so I'm going to have 1/2 amp up. And then finally, to find the remaining current, that's what I'm calling I3. You need to use my junction rule. That current's out, that current's in, that current's out. So it looks like I have I1 equals I2 plus I3. I1 equals I2 plus I3. A number of you got the signs all mixed up here. So, excuse me, I think that yeah, I'm looking for I3. So I3 is equal to I1 minus I2. So some of you didn't carry your signs down properly, and then that caused you to get this wrong. I1 here is negative 1/2. I3 is negative 3. So that's 3 minus 1/2, which is 2.5 amps. I came out positive, so that current was up. So it's also up 2.5 amps up. Okay. Uh, a number of you got 3.5 amps, which I just took off half. I think I gave you like 1.5 for that. What is the voltage on C1? Okay, so we've already seen this 3, 6, and 2. I know that that's 1. Let's go back to blue. The pink is a little anxious, isn't it? So I have 1 microfarad and 2 microfarads with my 6. Not ohm, microfarads, 2 microfarads, and then that just goes down to a, shoot, I'm sorry, y'all. It goes down to a 6 and a 3 in series. 12 volts. So I know what the voltages are. I'm going to have 4 volts here on that big capacitor and 8 volts here on the small capacitor. I want to know the voltage on C1. That's going to be 4 volts. If you didn't catch how I did that, so if you want to go the long way of getting that, you would say 12, and my equivalent is 2 microfarads, 12 volts. So this has a charge of 24 microcoulombs. I did C times V. 2 times 12 is 24. That means I have 24 microcoulombs here and 24 microcoulombs here. And then to find the voltage, I say 24 divided by 6, or 24 divided by 3, Q divided by C. All right, I tell you that this voltage is 12 volts. If that voltage is 12 volts, that means this is also 12 volts, which means that this is 24 volts, which is also the voltage across that capacitor. So let's see. The capacitors in series, the one with the bigger capacitance has a smaller voltage. What is the equivalent capacitance of this? Let's see. So we have, that's 1 microfarad, and then the 4 and the 4 is 2 microfarads, 1 over a quarter plus a quarter. That's equal to 2. 2 plus 1 is 3. D is the right answer. Hair dryer has a power of 1,000 watts. Voltage is 120 volts. I want to know how much charge. So first I need to know I. I is P over V. That's 1,000 divided by 120. And then I'm just going to keep it as a fraction for now. I want to, how much charge passes through the wire in 1 minute? Q is equal to I times T. That's 1,000 over 120 times T, which is 60. 500 coulombs. B. Which statement is necessarily true? The voltage across the voltmeter is small. Not necessarily. If you're measuring a small voltage, it's small. Ammeters are hooked up in series. Yes. The resistance of a voltmeter is big. Yes. We saw the ones in the lab were like 10,000 volts. The current through a voltmeter is small. Yes, because that is a big resistance, it also has a small current. Applied potential of 3 volts per electrical device. Current is 2 amps. Okay, so what we want to do is find the resistance here for both of these cases. That's 3 volts over 2 amps, 1.5 ohms. And then in the other case, it's going to be 6 volts over 4 amps, which is also 1.5 ohms. So this resistor remains the same, still obeying Ohm's law, uh, even though the voltage is changing. How does the brightness of bulb A compare to that of B? Oh, a lot of people miss this one. So if I have V right here, that means I have V over 2 here and V right there. I have double the voltage on the B. And the brightness of bulb A, remember, P is equal to V squared over R. Since I have half the voltage right here, that means it's a quarter as bright. So E is the right answer. A lot of you put D for that one. Wire has a resistance R. R is equal to rho L over A. If I double the length of the wire, and have the radius, which means that I'm quartering the area because area is pi r squared. So if I have this, I'm quartering the area. That means I'm going to have 8 times the new resistance. Which of these rules for resistors is correct? As you add resistors in parallel, the equivalent increases. No, it actually decreases. For resistors in series, the sum of their individual current is equal to the total current. No, they have the same current. Have the same voltage? No. Resistors in series, okay, yes, that one is correct. So A is the right answer. Consider these 3. Bulb B has a voltage of 2 volts. What are the voltages of C and D? So if B has 2 volts, that means that this battery is providing 6 volts because this has 2 and this has 2 volts. And if I have 6 volts there, that means this is also 6 volts. So I have D is 6 volts and C is 3 volts. So C is 3 and D is 6. What is central cross R3? Okay, simple combination circuit. I have a 2 ohm and a 4 ohm with 12 volts. If I go ahead and simplify it all the way, that's 6 ohm, 12 volts. That means I have 2 amps going right here and 2 amps going here. If I want to know the voltage across R3, that's the voltage across this resistor, which is just I times R. 2 times 4 is 8 volts. So I have 8 volts, 4 volts here, and 4 volts here. Because they're in parallel, they have the same voltage. What is the voltage provided by the power supply? So the equivalent of this is a 2 and 2 and 2 ohms and 2 ohms in series. If I have 6 volts there, I also have 6 volts here, which means that I have 12 volts here. These two are 6 volts because both resistors are identical. Okay. What is the current in this circuit? Yeah, I think this one was oft missed as well. I'm looking for this current right here. So 2 ways you could have approached this. I could have realized that the current right here has to equal to 13 amps because notice this junction. I have 13 amps going in, 5 and 8 going out. Okay, so that matches up. Um, and if this is 13 amps right here, that means that this has to be 16 amps. So B is the right answer. But I could have also looked right here that I have 8 amps coming in. Notice I have 5 and 3 amps coming here, so that means this is 8 amps. So I have 8 and 8 coming in, which is also 16. Either way is fine. Which of these equations is correct? I1 plus I2 is I3. Let's see, I1 plus I2 plus I3 should equal 0. For I1, I'm starting right here. Oh wait, no, I shouldn't have an I1 there, so that's not right. It should just be plus 4 minus 2I1. Here, minus 6, that means I'm starting here and going in this direction. Minus 6 plus 4I2, right so far, plus 8. That looks like the right answer. Let's check this last one. 2I1 is positive, so that means I'm going starting here and going in this direction. 2I1 minus 4, that's correct, minus 4I2 plus 6. Oh, that's right too. So it looks like D is the right answer. Oh, that was nice. I didn't have just C or just D, so that's good. Consider the second previous problem. What is the current through the 2 ohm resistor? So for the 2 ohm resistor, I'm going to choose what, the big loop. So let's start do the big loop. I'll just start right here and go in that direction. That's 8 plus 2I1 minus 4 equals to 0. 4 plus 2I1 equals 0. I1 equals negative 2 amps. So it should be 2 amps up. I didn't ask the direction, it's just 2 amps. Um, what is the current in the 3 ohm resistor? Well, I have 18 volts on both of these because they're in parallel. Current is V over R. That's 18 over 3 or 6 amps. Which of these in parallel is correct? They must have the same current. No, if they're identical resistors, they will. They'll actually each get half the current, the total current, but not necessarily the same current. Must have the same voltage. Yes, that's always true for resistors in parallel. The total voltage across the resistors equals, well, see, 3 is the opposite of what I just said, so no, that's not correct. The equivalent resistance is always less than the smaller resistor. Yes, so 2 and 4. D is the right answer. Connected in series, a 5 and a 4 with 18-volt battery. What is the voltage? So this is the equivalent of this is going to be a 9 ohm resistor, which is mean I'm going to have a 2 amps of current. So I have 2 amps here and 2 amps here. If I want to know the voltage across this one, I just say I times R, or 2 times 5 is 10 volts. By the way, look, I have 8 volts here, and 10 plus 8 is equal to 18, as it should be. And then 4 ohm resistor is connected across a 12 volt battery. Look, if I have a 12 volt battery connected to a 4 ohm resistor, then I should have a current equal to 3 amps. But I'm told that I don't, that I actually only get 2 amps. So in effect, it's like I, um, never mind. No. So what's happening to the rest of that current? It must mean that I have another resistor, and I want to know what is the value of that resistor. That other resistor is the internal resistance of the battery, and so if I would draw my loop rule, I'd have 12 minus I times R minus I times 4 ohms is equal to 0. I know what that I is. It's 12 minus 3R minus 3 times, excuse me, not 3, not 3, excuse me. I said it should be 3, but it's not, it's 2. 12 minus 2 times R minus 2 times 4 is equal to 0. That's 8 minus 2R is equal to 0, so R is equal to 4 ohms. Okay, let me correct that. You probably saw that. I didn't think it seemed right. So um, 12 minus 8 is actually 4. And so R is equal to 2 ohms. That's the equivalent, or excuse me, the internal resistance should be B is the right answer.